our demonstration of the camera and mine and Brandon's screaming, we demonstrated that the speed of light travels faster than the speed of sound, because the speed of sound travels at 343 meters per second, whereas the speed of light travels at 3 times 10 to the 8th. So, in our demonstration, it is very vivid that you can see the speed of light before you hear our voices.
Get closer, boy, that shows it right there, actually.
Yeah, that's pretty good.
Oh, that was right in my eyes.
What you just saw in the video with the laser in the crystal vase is that the laser is being refracted through the crystal vase, which makes its rays look like it's spreading, like kind of like a spider.
Sound is a longitudinal wave which consists of alternate areas of high pressure compressions. When I was playing the guitar, the reason the guitar works is because the guitar uses resonant string vibrations that causes the sound box to vibrate.
Okay, the clip you just saw of the subwoofers in my truck is just showing basically exactly what a sound wave does at different frequencies. At a 35 hertz bass tone, it's going to create more sound pressure at the bottom of the subwoofer, which is basically a louder sound wave. At 45 hertz, you have more air coming off the top of the subwoofer, and you still have air coming off the bottom, but more off the top than from a 35 hertz tone. From a 60 hertz tone, you have even more coming off the top and less coming off the bottom. Nonetheless, it's still both sound waves. This is more of a sound wave that you feel. This is more of a sound wave that you hear.
Okay, there it is. And what you see in the middle where there's no movement in those two spots are called the nodes of the wave.
And the higher the frequency, the more nodes you have. The lower the frequency, the less nodes you have. Now there's only one node because they're going slower.
That's the first one.
Like we saw earlier in the example with the spring it started off with 2 nodes, but then it moved to 1 when we lowered the frequency. And this is a drawing of how the node is in the middle of the two, it looks like it's 2 different springs, but it's actually 1, and the frequency of the wave makes it look like there is no movement in that one area.
The frequency is the number of complete vibrations per second. It is measured in hertz. The period is the shortest time interval which a point has its motion repeated, and that is in seconds. The period and frequency are reciprocants of another, so t equals 1 over f. The distance between 2 successive crests, troughs, or similar points is called wavelength. Velocity is how fast a traveling wave moves. Amplitude is the maximum distance from the rest position. To produce a larger amplitude, more work must be done, and more work means more energy. Particles cannot occupy the same space at the same time, but waves can, and that's called wave interference.
Right there, look at that. It is a rainbow.
Hurry up and video
I
it.
see it! A rainbow. When a rainbow is formed, there are several factors that are often overlooked. There's a secondary bow with the color spectrum reversed. The sky is lighter underneath the primary bow. The Doppler shift. The applications of these include the little blue football, radar guns, bats, astronomy, and meteorology. We have all noticed the change in pitch as a police car drives by with its sirens blaring. The frequency is higher and then it drops as the car passes by. As the car moves towards the detector, more waves are crowded into the space. Velocity is not changed because the source is still emitting the same sound in the same medium. Wavelength is shortened, so frequency must increase.